Just like the real thing, model rockets can provide the excitement and demonstrate the knowledge learned in the field of rocketry dynamics. Miniature transmitters and cameras can be carried aloft for you to test and to take pictures of your flights. If you've never built or launched your own rocket, then a whole new world of excitement awaits you. Everything from single-stage beginner rockets to the more sophisticated Star Trek command ship, Enterprise. When Brown, Goddard used model rockets to teach themselves the technique of rocketry. Now, that hobby has developed into a countrywide weekend pastime. Rocket kits are available, as are individual rocket packages. Manufacturers have taken great steps in providing scaled-down materials with strong guidelines and plans for rocket construction. It is important that you follow these plans, as we shall see later. Aerodynamics, rocketry dynamics are exacting even with model rockets. NASA has guidance systems that are electronic. Yours will be static. In other words, what you glue down has to be exact, or your flight path will be less than accurate. This rule follows for every model of rocket from beginner to expert. Follow the directions exactly. Cut all the parts to the right size, sand and shape properly, and don't be stingy with sealer, and use plenty of glue. Just as with professional and private pilots, your rocket firing has a procedural checklist. That is, prepare for your launch after your rocket is built, step by step. Missing any one step could cause a mistake further down the line, actually compound into a poor launch. It can be awfully embarrassing, for instance, to launch your new rocket only to discover a few seconds into flight that you forgot to pack your parachute recovery system. A checklist is necessary because of other variables. For instance, weather plays a major role in the angle of launch. Pilots use windsocks, and so can you if you wish to construct one at your launch site, or use a streamer or pennant, or the old standby, a little grass into the air. The simple truth is, however, that with the rocket engine, the rocket will in fact go somewhere. But where? Well, if the rocket is not stable, if its center of gravity has been shifted in construction or through some other force, then the rocket may fly erratic enough and end up nowhere. Every airplane pilot is aware of center of gravity and its meaning. To the pilot of an aircraft, the center of gravity is that point at his airplane where Earth's gravity is pulling against his aerodynamic lift the most. If the weight of their load shifts, then the center of gravity shifts, and they must adjust for this. Airplanes have horizontal elevators to assist with this, as well as variable power control. Model rockets have neither, and a model rocket will tend to spin at the center of gravity when unstable. The balance point, therefore, is the center of the rocket. However, with added weight, that of the engine, the center of gravity of the rocket shifts. That's one reason the nose cones for your rockets must also be mounted as straight as possible. There are forces working both for and against both airplanes and rockets. Thrust, drag, lift, and gravity. As long as the forces on the fins of the rocket are great enough to counteract the forces on the nose and any off-center thrust, the rocket will fly straight. Fins, therefore, must be straight, in line with the rocket body. Your construction plans provide special marking guides. The rest is up to you. With proper fins, your rocket will fly straight and true. With fins that are not the right size, your rocket will tend to seek its new center of gravity and end up flying nowhere. One other force that can affect your rocket's center of gravity and flight path is a side force or weight not accounted for in the design of the rocket. This rocket, however, is designed for a piggyback glider and flies straight and true with the glider mounted. The rocket returns by parachute, the glider is launched at the apex and returns on its own. The easiest way of testing the stability of a model rocket is to fly it without launching it. Make the test on your model by forming a loop at the end of a 6 to 10-foot string. Install an engine in the rocket. Slide the loop to the proper position around the rocket so the model balances horizontally. Swing it overhead in a circular path. If the rocket is stable, it will point forward into the wind created by its own motion. Move the string back a little and let the nose fall about 10 degrees. If it will still fly straight, it is stable enough for a launch. Now that we understand our center of gravity and its importance, we come to another important area: recovery systems. Most model rockets, just as the space capsules that carried our astronauts safely to their landings, use parachutes which are packed into the body of the rocket. Other recovery systems include streamers and tumble recovery, a motion that produces extremely high drag on the rocket so that it falls slowly. And helicopter recovery, thin vanes creating a high drag which keeps the rocket from falling fast. And glide recovery, such as the scissor wing. Our checklist points out one other important step: fireproof wadding between the engine and the parachute. Fireproof wadding is mandatory. Let me show you why. We built a plastic tube and installed a parachute, engine, and fireproof wadding. Don't use ordinary tissue, paper towels, or other non-fireproof wadding. In the air as high as 1,500 feet, this wadding, if not fireproof, could float, depending upon the wind, to a rooftop. Our plastic rocket allows us to see exactly how the parachute, carefully wrapped, is pushed into the body of the rocket above the wadding, followed by the nose cone. Now we've reached another similarity between NASA and model rocket firing. Our engines are ignited electronically. We have control and a countdown. But our checklist demands we carefully insert the igniter in the engine. Carefully inserted. 9 out of 10 failures are because the igniter was not inserted properly, and that means fully into the engine. Make sure the igniter portion is touching the fuel in the engine. Tape it down. Tap it with your finger or a pencil to secure the tape, and it should hold and fire. Clean the igniter clips and install. Arm the launch system and proceed with the countdown. 3, 2, 1, lift off.